for those of you who are here today for the first time, is we try to put on seminars to introduce you to different topic areas. And so when we were putting together potential speakers, one kind of came to mind when I first started making the list, and that was Bret Kugelmass. And so Bret Kugelmass is the managing director of the Energy Impact Center. Mr. Kugelmass is a successful robotics entrepreneur who, after selling his drone technology company in 2017, launched a research institute to focus on mapping out paths to tackle climate change. He is best known within the nuclear energy community as the host of the Titans of Nuclear series, where he's published over 200 podcasts and over 1,000 YouTube videos detailing his journey of discovery through this sector. It's one of those things. I've actually listened to several of the podcasts. I would recommend you guys doing it because, to me, it's not only interesting the diversity of the people that he's interviewed, but also you get to hear more of their story. And sometimes when you talk about science, it's one thing to talk about the story. It's one thing to talk about the people who are making the science happen. And that's something I appreciate from him. So in the last 2 years, he's done over 50 site visits to nuclear facilities around the world, met over 1,200 experts across technology, industry, economic policy, and more. And he is one of the newest and most vocal advocates for championing nuclear power, as he's spoken at a dozen universities, conferences on the topic, and we're excited to have him at Oak Ridge today. So please welcome Bret Kugelmass to the stage.
Did anyone else have a pretty surreal moment when they learned about the energy density of nuclear fuel? I mean, 1,000,000 times more powerful nuclear forces are than their chemical counterparts. For me, this was almost like a moment from the Matrix where you just never see the world in the same way again. And it was really the first time that I felt confident that we could tackle this climate challenge before us. And quite a challenge it is, bigger than most assume. So today, we're going to look at climate change and what some of the climate advocates get wrong. We're going to look at what some of the nuclear advocates get wrong. And we're going to devise a path out of this mess. Now, I'm going to say a lot of things that may not make me very many friends in this room. A lot of things that your professors, that your colleagues, that your bosses might say the exact opposite. But you already invited me, so it's too late. So buckle up and here we go. Let's start with just how big a problem climate change really is.
You see, what often gets lost in the public discourse is that the carbon in the air determines the rate of heat capture, not the magnitude of temperature. The implication of which
is that even if we eliminated all new emissions across every sector, we zeroed out completely industry, transportation, agriculture, heat, electricity, the temperature will still continue to climb year over year. So long as the rate of heat capture, known as radiative forcing, which is determined by the amount of carbon already emitted. I can't stress this enough, how synonymous the problem of climate change has become with reducing emissions. It is both a false equivalency and totally counterproductive. We need a total overhaul of our problem statement. In order to solve climate change, we need to remove carbon from the air. Let's put a pin in past emissions for just a second and talk about another problem that the public climate narrative refuses to acknowledge. That's just how valuable cheap energy is, and why keeping it cheap is in fact more important to society than preventing climate change. See, energy is food, energy is medicine, energy is buildings, energy is jobs, energy is everything that you love about a prosperous society. So when anyone proposes that a developing country should tax energy, artificially making it more expensive in any way, they don't have a conception of what energy actually is. This is why every country in the world makes the very rational decision to subsidize dirty energy, even as it kills people and the environment, since what often goes unacknowledged is that it has compounding positive effects on every other industry, on overall productivity, and most importantly, on people's well-being. If you don't believe me, consider this. China, which has enough building acumen and resources to build megacities from scratch in less than a decade. China, with a centrally controlled authoritarian government that can ban plastic bags overnight. China, who certainly knows how to make solar panels, which supposedly hit grid parity years ago. That same China continues to acquire half its energy from burning coal, smogging their cities, creating countless asthmas and cancers, and killing millions of their own people from air pollution every single year, rather than make energy even just a little bit more expensive. How could that be? Unless cheap energy has such incredible, intrinsic, unacknowledged value that for all but the absolute wealthiest in the world, nothing is worth pricing it higher. Take this example of air pollution as a dose of reality. Climate change is horrible. Poverty is worse. So why does this false equivalency between reducing emissions and solving climate change persist? I found at least 3 culprits. 1, confusion. Everything that I'm reading in the media equates the two. 2, denial. But Bret, if this were true, then my favorite solution just couldn't be part of it. And 3, rationalization. I know it's not going to solve the problem, but it's better than nothing, and at least it's a step in the right direction. So let's address these one by one. Confusion in the media. Our team has combed through hundreds of articles on climate change and found that journalists keep making the same 2 errors. First, they're not reading the axis of the graph. They see some lines going down on some models, and they don't read the fine print. That the rate of change can go down, while temperature can still go up. And similarly, they see graphs of models ending at 2100, and they don't bother to ask what happens after 2100 under these models. They just assume that the temperature is going to hold at the last value. But in any scenario where you have a derivative of position that's positive, even if you hit a target specified point, you're going to blow by it just the next year. That renders your entire exercise, but for a slight temporal shift, totally moot. Ironic for those who proudly claim to be on the right side of science, to care so little for math. False equivalency, culprit number 2. Denial. But Bret, if you're right about existing emissions, that means my favorite technology can't be part of the solution. That's right. This all-of-the-above approach is totally illogical. By definition, spreading your resources across all available options means the majority of your resources are being used inefficiently. Think about it. What does make sense is to start off with a subset of solutions. First, down-select whether the entire system can go net negative overall. And then, over time, as you collect more data, narrow even further based on cost effectiveness. There's a widespread denial about addressing previous emissions because this logic directly invalidates the most commonly lauded approaches. It invalidates efficiency because efficiency can't be used to remove carbon from the air. It invalidates diffuse, intermittent energy sources. Does everyone know what I'm talking about here? Capturing 1,000 billion tons of CO2 from the air, no matter which way you spin it, is going to take a lot of energy. So whatever system plus source of energy you deploy must be able to sequester more carbon across its lifetime than it emitted in building and operating it. The problem with diffuse energy sources is that they require a lot of material per unit energy capture as a fundamental property of the area that they must occupy. The more material means it emitted more carbon to produce it. The problem with intermittency is that the inverse of your capacity factor acts as a multiplier on your carbon footprint. diffuse and intermittent guarantees based on a total life cycle accounting, you're always going to produce more carbon than you can sequester. Okay, so if I haven't pissed off enough people with what's already here, here's what's most offensive to the climate culture we built. Requiring negative emissions invalidates individual action, because there is no mechanism by which individuals can permanently remove carbon from the air. And this might be too big a pill to swallow, because the climate movement is underpinned by a broad coalition of selling ineffective solutions to the global 1% based on a sense of individual responsibility. Culprit 3, rationalization. But what about the climate scientists who should know better? Who built all these models to begin with? You know those 97% who love to start every sentence with climate change is real? And ironically, in doing so, they actually elevate their detractors to the same stage of debate. Why do those scientists stop short of saying what we need to hear? That we need radical negative emissions to solve the problem. And more importantly, if we had radical negative emissions, we wouldn't need anything else. When pressed to defend their position, they say, well, reducing emissions is a step in the right direction. Well, first, mathematically, it is literally not a step in the right direction. Remember our derivatives? Everything proposed that has a positive carbon footprint, while it might be better than something with a worse carbon footprint, is in fact still going in the wrong direction. And for the non-mathematically oriented, think of a car. It is possible to have negative acceleration and positive velocity at the same time. And no matter how hard you press on the brake pedal, your car won't go in reverse. What's worse, though, is that the most commonly proposed solutions don't even have negative acceleration. Given existing emissions, per capita energy consumption growth, and population growth, they might have a negative snap or crackle. Okay, discussing the fifth derivative too much, fine. Let's use an analogy not just to criticize their math, but their communication strategy as well. Let's say you're mobilizing your nation to get to the moon. Would you deliver speeches about wanting to blow up your rocket shortly after takeoff? Because that's what the Paris Accord states. An objective of 2 degrees by 2100 and only getting worse after that? That's aiming for hundreds of millions to lose their homes and likely lives. That's aiming for widespread ecosystem destruction. That's aiming for a climactic holocaust. The Paris Accords are a nightmare, both mathematically and motivationally. What's crazy is that we've all just fallen into our tribal camps and go along pretending that the Paris Accords are a good thing because those scientists are supposedly on our side and that's the best they could do? Who put these wimps in charge? Maybe instead of hiding behind non-binding, non-enforceable, pyrrhic proposal, why don't we advocate for an actual solution? Stand up and say, we are America, the greatest nation to ever exist. We will defeat climate change now, and you, the rest of the world, can join us in sharing our glory, or wait around for us to save your asses. Maybe that doesn't sound nice, but I would rather our climate leaders be a little less polite and a little bit more effective. We didn't win World War II with a conference over croissants. America literally reinvented the laws of physics right here at Oak Ridge. We ended the deadliest war in human history with sheer technological ingenuity. Let's live up to that tradition and become the next greatest generation. Let's recognize that climate change is our new enemy, and a step in the right direction isn't enough. So we've discussed the problems and why misinformation persists. What do we need to actually solve this? Well, from a logistical perspective, we need carbon-neutral fuels. From a physics perspective, we need carbon-negative products. From an economics perspective, We need carbon neutral fuels cheaper than carbon positive fuels. And we need carbon negative products cheaper than carbon positive products. Carbon neutral fuels. Tens of trillions of dollars of transportation infrastructure and industrial processes are dependent on hydrocarbons. You know why? Because hydrocarbons are freaking awesome. They're energy dense with built-in storage, very stable, easy to transport, and are the backbone of nearly every advanced society has made since caveman times. They do have a problem though, and that's their waste stream. But if we mine hydrogen and carbon from the air instead of from the ground, we can pre-account for their waste, hence neutral. Create hydrocarbons from the air instead of from the ground, and we can instantly wipe out the carbon footprint of 7 billion people on Earth. Carbon negative products. We need to sequester 1,000 gigatons of CO2 that we already emitted if we want to halt additional warming. Well, you know another way that hydrocarbons are awesome? That's plastics. Plastics are another foundation of modern society and truly magical in their structural properties. Let's be very clear. Just because we don't want them in the ocean doesn't mean we don't want them. Tying those two things together is another way these so-called environmentalists have manipulated public guilt into creating new economic opportunities for themselves. Plastics are also incredible at sequestering carbon for thousands of years in an extremely stable and economically valuable form. A world in which we increase consumption and create more plastics from carbon in the air is a world where we perfectly align short-term individual interests with long-term global preservation. But economics. It is going to take 3 times as much energy to make hydrocarbons from the air instead of from the ground. So if we want market forces on our side, we need to use another fuel source cheap enough to facilitate this. That other fuel source needs to be more abundant and far more energy dense. What fuel source could that be? Yeah, nuclear, that's right. You guys want to hear what my second matrix moment was? You're not going to like this. It was the moment that I realized that 3 core meltdowns at Fukushima couldn't so much as manage to hurt a hair on anyone's head. But we'll come back to that later. Let's follow the same structure that we did with climate and talk about nuclear. Its problems, how our most vocal advocates are in fact making things worse, and we'll plot a path to success. There is one problem, and only one problem with nuclear, and that's that building new plants costs too much. Now, before you get panties in a knot about public perception being a challenge, the facts simply don't support it. Orders dried up in 1978 before 3 Mile Island because nuclear was too expensive. Orders dried up in 2008 before Fukushima because nuclear was too expensive. Dozens of countries right now are desperate to build nuclear, but nuclear is too expensive. Yes, Australia, Germany, California, Massachusetts, and a few other inconsequential energy markets have thrown hissy fits over the years. What's the excuse for not selling to the rest of the $5 trillion a year energy market that is clamoring for more power and loves nuclear because it makes them feel strong like a first world country? Public perception is a self-defeating excuse that nuclear engineers use for not building a cost-competitive product. We don't sell EPRs and AP1000s for the same reason we don't sell Segways. Over-engineering has priced it out of the market. Come up with a cheap energy product, and no matter what the critics say, the world will rationalize buying it. The same way that we rationalize buying clean coal, natural methane, and toxic solar panels. We have to drop our egos and realize that the price of modern nuclear power is not driven by inherent complexity, but rather a culmination of bad decisions that drive up cost, scare the public, and yet stubbornly maintain industry-wide support. My team spent the last 2 years compiling dozens, but I'll give you 4 right now. 1, large construction sites. I almost couldn't believe it when I saw last week that Vogtle was bragging about having 8,000 workers on site. Yes, more jobs are great, but what we want is 8,000 jobs across 8 different projects that only require 1,000 people each. Make a cheaper product, and you'll drive job growth by selling more of them. Vogtle's construction design choices have guaranteed there will never be another gigawatt-scale nuclear plant built on American soil again. That's bad engineering. Forged pressure vessels, number 2. Does anyone know why the industry requires forged pressure vessels? We didn't used to. Out of curiosity, I called up a few manufacturers to understand what the difference in price was between welding and forging. It was 100-fold. $1.5 million versus $150 million. The roots of this requirement come from experiencing radiation-induced embrittlement of the weld filler material, which in the 1960s contained copper. Well, guess what, folks? We have new weld filler materials, and we have welding techniques that don't require filler at all. To stick with forgings is emblematic of how conservatism and tradition drives bad engineering. A good engineer does not design the strongest possible equipment. They design the cheapest possible equipment that satisfies strength requirements. Number 3, airtight containment. You guys know the difference between a hot pot and a pressure cooker? It wasn't the hot pot used at the Boston Marathon. Yet we require designing nuclear pressure cookers with hydrogen as the fuel and radionuclides as the shrapnel, increasing cost and decreasing safety. The design goal is to limit the flow of radionuclides in the case of an accident. That is antithetical to requiring a fixed volume in the presence of a heat source. Just having no requirement for airtight containment means no pressure buildup, no hydrogen buildup, and 99% of the source term is no more than a few feet. A few radioactive gases could escape, instantly dilute, and become a totally harmless part of our atmosphere. Just like the sun creates totally harmless radioactive carbon-14 every day. Instead of accepting a little radioactive gas escape, we create a dispersal mechanism for otherwise non-mobile sources and demand an incredibly expensive structure to facilitate this. Light water or any reactors with inherently negative neutronics don't need containment. They need confinement. A strong roof is both safer and 100 times cheaper. We sit here criticizing the Fukushima operators for keeping generators in the basement when we sold them a plant that traps hydrogen. Let's take a little responsibility for our bad engineering. Mistake number 4. Evacuation. You guys remember my second matrix moment? As far as radioactive release goes, Fukushima was as bad as it could ever get for a light water reactor. The largest tsunami earthquake combo civilization has ever seen took out every single safety system, spilling 3 gigawatts of core melt on the floor. An expensive mess, but not a hazard if you just stay out of the room. Then our genius pressure cooker design shot it out of the building, and even then, it was in such low quantities that no one was ever in any risk. A competent emergency plan shouldn't even have evacuation on the table. But what's the nuclear way? We behave as if a meltdown is the greatest possible emergency that could ever occur. And we convince the rest of the world that too. So as a response to this attitude, the Japanese government goes in, and the first thing they do is unplug 1,000 elderly from vital medical equipment, evacuating them from the remainder of their lives. After that, they forcibly remove 100,000 people from their homes for years, while they systematically destroy their land. All to clean up an insignificant amount of radioactive contamination. Chernobyl taught us exactly how much and what type of radiation causes harm. Fukushima proved that no light water reactor could ever come close in any circumstance. But instead of sticking up for ourselves and shouting from the hilltops that we should have less regulation than a campfire, we cower in fear and invent even more systems, further driving up cost. That's bad logic, it's bad leadership, it's bad engineering. Why is this? Why are some of the smartest people that I've ever met responsible for some of the worst design choices that I've ever seen? I've got 2 words for you. Safety culture. I have never seen a more powerful and more heinous tool. We all know that in nuclear land, arguing for safety wins every argument, even if the result is less safety. Selling safety is selling fear. It scares the public. It doesn't appease them. Safety is responsible for those domes that built up explosive hydrogen. Safety is responsible for evacuations, which, unlike light water reactors, do kill people. And even worse, safety is responsible for driving cost in every aspect of nuclear power, pricing it out of the market, and enabling the proliferation of every other, less safe energy source. Next time you hear someone criticizing the Russians, consider this math. Or Chernobyl every month for the next 100 centuries would be safer than letting coal persist for even 1 more year. And we are responsible for coal by not allowing humanity a cheaper option. We say safety is our #1 priority, but what we mean is selling nuclear safety is our #1 priority, not making the world a safer place. Okay, to recap. The only problem nuclear has is cost. Just like with climate, we've identified several self-defeating nuclear narratives. Now we just need a solution for cheap nuclear power so we can produce carbon-neutral fuels and carbon-negative products. Now, despite everything I just said, there are 2 really simple, albeit not sexy, fixes to the nuclear cost equation. Solution 1, hire competent construction managers. Even with all the additional nuclear-specific constraints, it has such an overwhelming advantage from a fuel perspective that better project management alone would make it cost competitive. Build the plant smaller and faster, borrow less money for shorter construction times, and it'll be the cheapest power on planet Earth again. Solution 2, redefine radiation standards to match reality. Excessive radiation protection adds tremendous direct and operational costs to every aspect of a nuclear power plant. We control for radiation at levels 10,000 times smaller than anyone has ever been hurt by it. The radiation standards bodies time and time again reaffirm findings that contradict their own research. Their behavior is borderline criminal, and we enable them because it bolsters our current business model and ideology of selling ever more safety at existing facilities. We need a single country with the guts to stand up to these so-called medical professionals and throw out the linear no threshold model. Their claims of radiation's effects on genetics was locked in by 1947. That's 6 years before we even discovered DNA. It's a relic of past ignorance. And if you destroy it, nuclear power will reign supreme. As I conclude, just remember, you here are the masters of the magic within the atom. You hold the keys to saving the world from climate change. Don't let fear hold you back. Thank you.
Okay. It looks like Bret has allowed us a little bit more time to
Do some Q&A.
do some Q&A. So would anyone like to start the discussion with something that has been said or something that you've been thinking about? Okay.
So you talk about the importance of energy subsidies and lowering the cost of energy and providing it to thousands, millions, billions of people. But don't you think that these subsidies, in addition to lack of any sort of carbon pricing, is part of the reason nuclear is priced out of the market at the moment?
I don't think there should be subsidies at all. And I don't think nuclear needs any subsidies to beat every other energy source hands down. Carbon pricing is an interesting tool. It's an interesting tool in that it changes the market forces. I think the market forces are good enough as they are. If you take away all of the additional burden that regulation puts on nuclear energy. I mean, the fuel is essentially free, right? Everyone talks about how cheap natural gas is, right? The fuel of nuclear is essentially free. The system acts almost in steady state for 2 years. Where's all this cost come from? It comes from the extremely expensive construction that we put into it. And it comes from having 800 people doing safety checks for 2 years straight while the reactor produces energy all on its own. Please. Yes.
It was a really good talk. I have a question regarding the infrastructure of the current coal or natural gas power plants. If it replace them by nuclear energy, how sufficient is the current infrastructure to hold and produce energy and reach it to common people?
I think that if we want to do this fast, and by the way, we need to do this fast. We're talking hundreds of millions are going to be displaced from their homes in the next few decades, okay? If we want to do this fast, we can't cast aside all of our fossil infrastructure. We need to utilize it. I mean, there's tens of trillions of dollars of investment and people working in them that know how to move energy around the planet, right? We need to utilize this. This is why we need to have nuclear energy that is so cheap that we can build those same hydrocarbons from the air, rendering them harmless in effect, and distribute them through the existing hydrocarbon infrastructure that we have today. It would be the least shock to the system as well. Most people would just keep their jobs. And we have, where we need to build about 10,000 gigawatts of nuclear to start producing those fuels and shipping them around the world.
You talk about removing CO2 or carbon and hydrogen from the air and creating fuel from these things. Is this technology anywhere close to being something that we can actually do?
If you're asking, is it close in terms of when you have extremely high energy prices? No, it's not, and that's why we're not doing it with renewables right now. If you have incredible abundant amount of energy, yeah, you just use different processes that we've known about since the early 1900s. There's nothing complicated about tearing apart a CO2, the bond in a CO2. There's nothing complicated about tearing apart the H2O molecule. It just requires a ton of energy. And so the reason that it seems as if these technologies aren't very well developed is because everyone's trying to do it in a very energy efficient manner. I'm saying do it in a very energy wasteful manner if you have extra energy to use. And that's why nuclear is so important here, because it is the only energy source that can enable that.
So you talked a bit about public perception of nuclear. You didn't really address public perception of climate change. And I have co-workers, engineers here at Oak Ridge that call it a hoax.
Yeah.
So how are we going to address any of this until we can change people's minds?
It's a false narrative that they are what's holding us back. It's the same excuse that the nuclear people make for the reason nuclear is so expensive, because people don't like it. It's the same excuse that the climate change people make. They don't have a solution, so they just blame it on the people who call it a hoax or who don't like doing anything about it. When people say they're calling it a hoax, what they're really doing is they're expressing their values, right? It is possible to have people with different competing ideologies and the right side win, even if the other side is very vocal. Fine, call it a hoax all you want. I suspect they're mostly calling it a hoax because they don't want to be taxed more for something that they kind of know isn't going to work, right? My dad is one of those people. My dad thinks the climate change thing is a hoax. And the reason he says that, I don't think he really feels that way, but he's picking a side. He's picking the side of not wanting to be taxed for something that he knows, because he's lived a long life. He's been around. He's seen politicians ask for money for things and not deliver. And so I think that's the sentiment that he is representing when he says that. But once again, it's just an excuse that the right side makes for not doing anything about it.
So a big point that you made of why nuclear is too expensive is bad regulation and bad engineering. What type of strategies would you suggest to convince regulators to remove over-regulation on, say, containment and radiation release, and trying to generate data on something like improving the no threshold cleaner?
Yeah. I think, I actually don't have the answer to that, but I think if we were able to have a consensus on throwing out the linear no threshold model, you could bring that to the regulators and say, listen, your risk models were off by orders of magnitude. Now let's apply the new risk models with this science to show that a meltdown of a light water reactor can't cause anybody harm. The whole industry is built up on this thesis that it is such a horrific event that it is worth almost any expense to prevent a meltdown from happening. And that's why Fukushima was such an important moment for my own self-discovery of what the challenges we're facing are, because it proved that 3 gigawatts worth didn't emit enough radiation to hurt anybody. And then there's always the back and forth. Some people say, oh, well, it's because of the safety systems that didn't hurt anyone. Nope. All the safety systems failed, and 2 safety systems acting in concert made it worse. And some people say, well, it's because we evacuated it. Nope. There was at no point that the radiological contamination outside the site boundary ever posed any hazard to anyone ever. Now, if you can convince existing regulators of that, good luck. I mean, it would literally mean that they don't need to have a job. So I don't think that culturally you can just convince a regulator of that. I think over time, maybe if you bring the new radiation data to them or work with regulators who aren't so entrenched in their current beliefs, it would be a much faster path to market.
So given the current emission levels, like how much of the world would have to adopt this nuclear energy and using it to remove hydrocarbons before negative emission levels occur?
How much of the country or how much energy are probably 2 different questions there. How much of the world? How much of the world? 1 country. 1 country could build tens of thousands of gigawatts of nuclear energy. Greenland could become the synthetic Saudi Arabia and ship hydrocarbons made from the air around the world and literally become the richest country in the world in doing so. So it only really takes 1 country to solve all of climate change. No consensus, just build cheap hydrocarbons, climate wins. How much energy? I think in the tens of thousands of gigawatts this would take. to make this a reality.
Oh, just like as an estimate, how much do you think it would cost to build this many reactors?
Well, if you're selling it, it almost doesn't matter. If you're making a profit off of it, great. So if you're able to produce, a unit of energy for a cost-competitive way across the world, who cares how much it costs you to make? The more, the better, because then your top line is higher, and you can capture the entire market. So if you're making a profit, it totally eliminates the whole cost argument.
You'll never get it financed up front, though. People won't pay for reactors because the cost just escalates forever with like Google. And I think investors expect to see that of nuclear going forward.
That's right. So someone needs to crack the cookie on cheap nuclear and prove to the world it can be done. And then exactly what you said, that barrier that investors have will be broken down, and it'll open the floodgates of dry powder that investors have today. They're sitting on $1 trillion that they want to invest in technology companies. $1 trillion, but nothing looks profitable enough for them. If someone can prove that you can build nuclear cheap, all that capital becomes instantly available.
Hi. You talked a little bit about the hopes behind climate change, and that kind of originates from these fossil fuel companies like ExxonMobil, who knew that climate change was happening and did scientific studies, but put an enormous amount of money and lobbying efforts into covering it up for their own economic interest. Even that's still sort of a problem. How do you see nuclear getting political traction, given that there's so much monetary backing in politics from fossil fuel industries?
Make them your friends. I think the nuclear industry needs to give our magic secrets of the atom to the fossil industry. Use their power plant engineers, use their capital, use their ability to deploy technology around the world. I think we need to give it to them. We need to bring them in on it and let them be the winners. Fine, we save the planet.
You haven't touched on the issue of nuclear waste. While I tend to think they're good technical solutions to that, the barriers seem to be political. So how would you go about addressing that if you're growing nuclear power by these large amounts?
I think this is a pretty, this is another self-defeating narrative that the nuclear industry has. We say, people don't want it until we deal with the waste problem. Not true. You can build a new reactor and keep the waste on site. That's not what's stopping us. I think the question that we need to ask ourselves is, why have we characterized waste as something that is harmful? Nuclear waste has never hurt a single person, place, or thing in all of human history. As with most wastes, if you dilute it, it loses its efficacy. Instead, we decide to concentrate. We decide to bundle it up. They used to just grind it up and dump it in the ocean. That was the technically accurate thing to do and the cheapest way to handle it. But, like with many things in nuclear, when we lost our power industry, we invented new industries for ourselves. Cleaning up waste, especially at Hanford, is a $2 billion a year nuclear industry, right? That's how we make our money, by selling the fear of waste and then selling technical solutions that drive revenue to us and usually come from the taxpayers and in the process make everyone hate us. So I think we need to just totally reframe the question about nuclear waste and dismiss it as a hazard to human health.
So jumping onto that bandwagon, but a different avenue. So I would say that nuclear waste is not dangerous, but plutonium, which can be made in a reactor and we have put into a device, very much hurt people. How do you overcome the dangers of misusing nuclear power with trying to increase the amount of nuclear power that we use?
It's another false narrative that the non-pro community puts out. If nuclear fuel has been in a light water reactor for more than a month, it's ineffective plutonium is ineffective in terms of being used as a weapon because your ratio between plutonium-240 and plutonium-239. So people say, oh, well, there's plutonium in waste. Okay, well, not the right type of plutonium to hurt anybody. So it's just not an issue if we use light water reactors and other types of reactors that keep your fuel source inside while it builds up that ratio, plutonium-240, plutonium-239.
All right, so this does sound great and all, but if these cheap, better engineered versions, not over engineered, but better engineered versions of these power plants can be made, why hasn't it happened? Especially in a developing country that has less to lose, less bureaucratic overregulation, a lot more to gain from Greenland, yeah, something like that. Why is it just not happened yet? And when do you think it will, if you do think it will?
I don't know, why am I the first person that I've ever heard publicly say that we should make nuclear reactors less safe? Right? Everyone who knows how to make a nuclear reactor, everyone has the confidence to build it, everyone who any investor would trust building it, wants to just make them more expensive. So far as I've met, across 1,200 conversations with the nuclear company.
I just want to applaud you for so beautifully articulating what the majority in our industry actually believe, but also the majority of people are too afraid to say in a public forum, so thank you for that. How can we better articulate or get those folks like NEI that are standard bearers for nuclear industry to articulate in a way that is understandable and clear the way you do?
Be careful what I say here, because I have a lot of friends who work at NEI. But NEI is not the appropriate advocate for new nuclear. If anything, they lobby and they advocate for existing nuclear assets, for life extension, for other programs that drive money into the nuclear industry. And unfortunately, a lot of what drives money into the nuclear industry, safety, radiation protection, waste disposal, are the exact same things that make nuclear expensive. So if you need a political organization to get involved, I think it has to be a different one, along the lines of my thesis. And I'm not sure this can happen in the US. I think there are a lot of barriers beyond politics that'll make this far too difficult to ever build the types of reactors that I'm espousing in the United States of America. Now, it can still be an American company that does it, but it'll be very, very difficult here.
Hi, you mentioned building like 10,000 gigawatts of capacity. I had a couple of questions within, so for example, fuel cycles. If you were to build that much capacity, your demand for fuel will go up, and if you step to the traditional ones to recycle, you would probably drive up uranium prices quite a bit. And I'm not sure what kind of reactor design you're envisioning, but is there like a certain advanced fuel cycle with advanced reactor type that you're envisioning, or is it still like an LWR kind of design?
There are incredible advanced reactor technologies that are out there. I don't think that they're going to be the first ones to market and to really show how cheap nuclear can be, but I do think that they will be the future after this foundation is already established. The fuel problem at large is a bit of a misnomer. People thought we only had 100 years worth of fuel, but that was at a very specific price point. We can mine uranium from the ocean at like something ridiculously cheap relative to the power output, something like between $200 and $400 a kilogram. And because the ocean leaches uranium from the entire crust of the Earth, you'll never diminish its supply. So the most expensive that uranium will ever be to mine in unlimited quantities, right? Because there's something like 25 billion years worth of uranium in the crust of the Earth at current power consumption. The most expensive it'll ever be to mine will be something like $400 a kilogram, which is a negligible price increase in the total power output since the fuel comprises such a small percentage of your levelized cost of electricity.
Very nice talk, Bret.
I think you, like me, realize that probably in the next 30 to 50 years, there's billions of dollars that are going to go into electricity, going to go into energy. And so that puts us at a very unique point in time. If we believe your thesis, then we're either going to make choices or have to make choices that's going to greatly accelerate climate change, or we're going to have some solution. So my question to you is, how quickly does that solution have to come in order to avoid a very large mistake in the next decade or two? And are we ready to make that?
This is going to be pretty horrible to hear, but I think no matter what, we're already going to be in a position where hundreds of millions are going to die due to climate change, and what we can do now is try to prevent billions. Can we do it? Hells yeah, we can. We just need to take a very assertive position, drop some of our prior assumptions, and not be afraid to say the opposite of what all of our friends and colleagues and professors and mentors said to make this a reality.
All right, let's thank Bret for the great discussion.